So we're given this graph of a function and we want to draw the gradient function. So identify turning points. So there's one there, and that means the gradient is 0. So we plot it on the x-axis. And there's one here, so we'll plot that again. So these are points where the gradient, remember we're plotting the gradient here, as 0. Now if we look down here, the gradient is positive. That means it needs to be above the x-axis. It's very steep down here, so it's a high positive number and moves in towards 0. So that's going to come down like this. Now, in between the turning points, we can see the gradient is negative, and it's steepest about here. This is known as an oblique point of inflection. So the gradient 0 there becomes more negative, then starts to get shallower in towards 0 again. So that's going to give us this sort of shape. So where it's most negative, it's further below the axis. And then here the gradient is positive again, and it's getting steeper, which means that the gradient function has a greater value. Now if you look at this, this looks very much like a cubic, and this looks very much like a quadratic. And we know that if we differentiate x cubed, we get 3x squared. So we're going to expect to go from cubic to quadratic.